first section of notes today is titled Changing, Logarithms, and Exponential Form. Logarithms will be a brand new topic for this chapter, and exponential form will be similar to the graphs that we did earlier. The one definition for this section is log, which stands for logarithm. We'll have a small a, kind of like a subscript after log. We'll have a big B, which would be the base, and equals C. If you read this out loud, this would be log B, base A, equals C. And we're going to change that to exponential form. A is going to be the base, C will be the exponent, and it'll be equal to B. If you have three numbers in log form, you can match up the letters and switch it to exponential form, and vice versa, you can go from exponential form into log form. The only thing that changes is the log is not represented in the exponential form, and also B and C switch sides of the equations. The first problem we'll do is log base 5, 125 equals 3. Again, log 125 base 5 equals 3. If we want to change that into exponential form, A is equal to 5, B is equal to 125, and C is equal to 3. You can just rewrite it in exponential form. A would be 5, C would be 3, and B would be 125. So exponential form would be 5 to the third power equals 125. Also, you can take an exponential form, such as 8 to the third power equals 512, and we can change that into log form. Log form will start with log. Again, going back to the exponential equation, A is equal to 8, C is equal to 3, and B is equal to 512. We can match up the letters and rewrite it. So A would be 8, B would be 512, and C would be 3. So 8 to the third power equals 512. In log form would be log 512, base 8 equals 3. The next section of notes is titled Evaluate, Logarithms. First problem is log base 2, 16. For this problem, we can use what we just did with log equations to make this an equation. We can put an equal sign, and we don't know what it's equal to, but we can use a letter x to represent what the answer would be. Once you have a log equation, you can switch that around to exponents. Again, using A, B, and C. And that problem would be 2 to the x power equals 16. To solve this, we need to figure out 2 to what power would be 16. And that would be 4. So our answer, log 16 base 2, is equal to 4. Last question for this section. will be log base 9 to 43. Again, just like before, if it's not an equation, we can add an equal sign. We're solving for this expression, which we can set equal to x, and we'll find out what x equals. Switching this again to exponential form, the 9 will become the base, the 243 and x will switch sides, so it'll be 9 to the x power equals 243. For this question, we can try and figure out what x is equal to. 9 squared would be 81. 9 to the third power would be 729. So there is no integer or whole number that solves this one. What we can do instead, though, is change this 9 to a different base, such as 3. 3 to the second power would be 9. Bring the x down, and then we can figure out 243 would be 3 to what power? Multiplying out, it'll be 3 to the fifth power. And like the previous sections, when the bases are equal, we can cross those off and ignore those and set the exponents equal to each other. Solving, you get a fraction x equals 5 over 2. And again, there was no whole number integer, 9 to some power, that's 243. That's because the answer was a fraction, 5 over 2. But you can still solve this question by changing the bases and solving it that way. The last section of notes today is titled Solving Log Equations. First problem is log base 9 x equals 2. Same steps as before. Anytime you have a log equation, you can switch it into exponential form and then solve. For example, the 9 would be the base, 2 would be the exponent, and it would be equal to x. 9 squared is 81, so x would equal 81. Second question, log base 10, parentheses, x squared plus 1 equals 1. Same thing as before, we still have our 3 letters here, A, B, and C. We can switch them around to exponential form, which would be 10 to the first power equals the entire expression, x squared plus 1. 10 to the first power would just be 10, so we can ignore the 1. Solving for x, we can subtract the 1, and taking the square root would be 3, and we'll also have negative 3 as an answer for log equations. Just like in exponential equations, the log number has to be positive. If we plug a 3 or negative 3 in here, when it's squared, it'll be changed to positive, so they'd be okay. But for log equations, the number you're taking the log of has to be positive, it cannot be negative.